Okay, folks. Now, next topic that we've been hearing a lot about, an update on the Upper Missouri River Basin project from Nathan Edwards, the South Dakota State Mesonet. Nathan, I'm going to turn this over to you.
Thank you. I'm going to start out with a couple definitions. Oh, sorry. Okay. First, when I'm talking about the Upper Missouri River Basin, actually what we're instrumenting as the plains of the Upper Missouri River Basin. That's basically this green area here minus the portion that's over 5,500 feet. So that's everything upstream of Sioux City, Iowa, that is below 5,500 feet and is not in Canada. There are a couple thousand square miles in Canada, but most of that's above the elevation anyway. So anyways, the other thing I want to define here is total water monitoring. I kind of feel like a Johnny Appleseed for total water monitoring, and I feel really lucky to be doing it right now. And what that means to me is precipitation, which in my part of the country involves snow depth as well. And then also evapotranspiration and snow sublimation. I'll clarify why I stuck those two together. And then also soil moisture and soil temperature. So, all right. So our problem is we've got an issue. We're not getting enough data to our product, to our different data products. This was identified after the 2011 flood, which like exceeded the capacities of some of the dams and that kind of thing. There was a lot of property damage associated with that, and it got on the radar at the federal level. So basically, the kinds of things that we need to feed are the National Weather Service has a couple models that they run. One is to model the forecast. That's the SNODAS model. The other one is the Sacramento model, which you heard mentioned earlier in the Colorado discussion. And there's a similar model that the Corps of Engineers runs that's called the HEC HMS. And then what spawned this really was flooding, but what's good to tell if there's too much water is generally good to tell if there's not enough water. And there was a demand for better data for the U.S. Drought Monitor too. So basically this list here is what we built to satisfy. The I'm kind of getting at this problem. So in most years, the water that ends up in the dams comes from high elevations above 5,500 feet. Those are instrumented by SNOTEL. And the SNOTEL does that job well. They got their bases covered with that. It's in the years like 2011 where you have a bunch of plain snowpack and you have no idea what the soil moisture profile looks like there's just a big blind spot there. The capacity of the near surface soil in the Upper Missouri is 3 times the reservoir capacity on the Missouri River behind the dams. And it's effectively a reservoir in and of itself, and they don't have a way to know what they're dealing with as far as management is concerned. So anyways, before the project started, this is what we were looking at. This is a density map of soil moisture monitoring in the United States. You can see New York, Oklahoma, and Delaware have some good coverage. In Utah, we got a stripe through Utah here. But the Upper Missouri River Basin was really lacking in a lot of data. This is for soil moisture, but it's pretty similar for total water monitoring variables in general. So at the dense, like the way to solve this problem then, well, first I'll mention the partners. There's 5 Mesonets involved in this project. us, South Dakota State University, North Dakota State University, the University of Montana and Wyoming, and also the University of Nebraska Lincoln. The big federal partners involved are the Army Corps of Engineers and the National Weather Service. And then we got a ton of other partners too, like NRCS is doing soil sampling for us and lab work on that from each of the sites. NIDIS is doing the data value study and the mapping project. Um, the the feedback that we've gotten from data users has been super helpful. We're working with tribes a lot. That was one advantage of going with the state Mesonets to do this instrumentation, is there's already a lot of close development with the tribes, that like close relationships that have been worked out with the tribes. For example, all of the new stations that are going in South Dakota, those are all available in Lakota, both text and speech. Private landowners are a big part of this. A lot of these are ending up on private ground. And there was a question earlier about the political nature of what we do. This had broad bipartisan support, and of course, many, many others. So the way that you solve this problem, when I talk about total water monitoring, I'm not just talking about what variables we need to look at. I'm also talking about getting sufficient spatial coverage. And based on a lot of previous work done and what modelers wanted to see, that means 1 per 500 square miles. And here you can see the whole upper Missouri River Basin plains divided up into 500 square mile boxes, with those like colored by the university that will be instrumenting them. That works out to 540 stations altogether. And the coverage area is over 250,000 square miles. This is an example of one of the stations. You can see the natural cover plot in the foreground there. Each of them has a weighing precipitation gauge, because traditionally most Mesonets measure rainfall only with a tipping bucket rain gauge. And because high rain rates are getting high rain rates is important, and also collecting snow is important. We use weighing gauges. They're all shielded. Most of them have heated rims as well. Snow depth sensors, because really, if you think of the snowpack, it's precipitation that hasn't fallen all the way yet. So we gotta we gotta measure it between when it's fallen into the gauge and when it actually melts to go into the soil or sublimates. So we've got temperature corrected sonic snow depth sensors. We also do ET or snow sublimation. The reason why I lump these together is you need temperature, RH, wind and solar radiation to do both of those. And so it gets us some extra mileage out of stuff that we traditionally used only during the summertime. One thing that there is a benefit here to having a heated pyranometer. I'll mention that. And by and large, and there are some legacy ones with North Dakota and with Nebraska, but the bulk of the probes going in are the Acclimate TDR 310Ns. And we're doing what's kind of becoming the standard profile of 5, 10, 20, 50, and 100 centimeters. Interestingly, we have one of our stations used to be a co-op that started, well, actually before the Signal Corps, before South Dakota, in the 1880s. And it did soil temperature, manual daily measurements at those levels. Anyways, another thing that we're doing is cameras. These have different applications that we're finding all the time. It was there primarily. If you look in the picture on the left there, you'll see there's kind of a marker by the snowboard. That snowboard is underneath the snow depth sensor. It's kind of a crude yardstick of sorts so that you can double check the measurement that you're getting out of that. Another thing it lets you do is it lets you gauge representativeness of that measurement versus the area around it. Another thing that we're finding applications for is things like looking at vegetation green up and dry down for drought monitoring, for example. So on soil moisture, we're obviously getting volumetric water content. We want to be able to get that into available water and then also into quantities. There's 5 different quantities in the Sacramento model. We'd like to try to get them into those to see what kind of comparisons we can make there. So this is where the soil sampling comes in. There's a lot of work that is done on these soil samples, but the important list that we're getting out of it for this is the bulk density, the 1/3 bar, sometimes the 1/10 bar. That's kind of hit and miss. The 15 bar, oops, at the depth to restrictive layer, and then also the curve number, or what we need to come up with a curve number. This is an example of soil sampling done at a station before it was upgraded. It's typically, I think this one was 80 inches, but typically I think 60 inches is the modern one. You can see there how they've got bags strung out for bulk density measurements, that kind of thing. So they do some of the work in the field and then they send the rest to the lab. A subset of the soil metadata will be available alongside of the data. The rest of the data will be, or the rest of the soil, the rest of the PEDON report will be available through NRCS, like for people that want to get into every bit of it. Then I'm going to bring up here, we're working on a way to map this for the purposes of primarily focused on drought. It will certainly have other applications as well. We've got, so this is because we are dealing with stations with short periods of record, what we're doing is doing a change in volumetric water content. So like a 1-week change or a 2-week change, or in this case, a 12-week change, and using that to give an idea of change over time. We're working on the stuff that Ronnie was talking about, the available water. I don't know why this is getting ahead of me here. We're working on getting available water stuff. It doesn't do this currently, but we're also working on carryover values so that you can compare to frozen periods. The below about 2C or so, actually this is the QR code if you guys are interested in looking at it. But we're working on a way to be able to carry over frozen values from getting a good value right before they froze and then carrying that through the frozen period. I'm sorry, did you guys miss the QR code? To be able to carry over the frozen values rather than just saying that, like, say, it was discussed earlier, like saying take a value in November and then carrying that over. Things can happen, things can thaw out and then refreeze and stuff like that. So what we're looking at is taking the measurement immediately prior to when it was frozen. But by immediately prior, I mean when it was at 2C, and then carrying that over. It's fairly bulletproof. There's not a lot of things that change soil water content in that regime. And like when it comes out of that, a lot of times you want to know what happened. Like a lot of times the snowpack and the soil moisture thaw at the same time. And you want to know like what impact did that have on changing the volumetric water content in that kind of, in the springtime. So anyways, I guess I got, I'm actually done on time. Yeah, questions? Actually, you know what? I had scribbled down some notes. People were asking what can we get out of the National Coordinated Soil Moisture Monitoring Network? There is the joint effort by the community um, in that regard has has had a huge influence on the upper Missouri River Basin. When a whole group of experts get together and say, this is the way we want to see the data, or this is how we think it should be done, that has a lot of weight. We know that we're headed in the right direction on things. And there's a part of the strategy document that you saw noted earlier, and there's a few bullet points in that: completeness, accuracy, low latency, associated measurements like precipitation and ET, and then characterizing the soil of the sites, having photos to go along with them, maintaining a long period of record, and getting good spatial coverage. So, anyways, that was something that I kind of wanted to add, like when we were kind of talking about what the value might be. That's if it is a very thick document, but going through that strategy document, I think is really worth it. There's a lot of really talented people put a lot of work into that. So yeah.
Can you explain again how it was chosen that 500 square miles would be the network grid?
So the asking about the density of 1 per 500 square miles, that kind of dates back to two things. 1 per 500 square nautical miles was um, what was come up with for a um, the modernization of the co-op that was done years back, and that was basically the same data set: wind, temperature, relative humidity, soil temperature, soil moisture, that kind of thing. So that was part of it. Uh, that was also based on um, there's another uh, the National Academy of Sciences had one for soil moisture that set a goal of 1 per 1,000 square miles for soil moisture. Um, since we needed a higher density for precipitation, uh, and since we're already in a spot, we just made the step to double it for soil moisture. But um, that's where that comes from. And then we vetted all of that with the models that we were feeding. One thing too, I would say that's not so much that's, I mean, a lot of the models are working on actual distances. A lot of the stuff the USDA does is based on counties. And so what we're trying to do is get one to the best that we can in every single county. 500 square miles is about the size of a small county. So that works out pretty well too. A lot of that is more on political boundaries, but we try to, for the most part, this is done. We're trying to be representative of each 500 square mile grid, but where we can, we're trying to move that into county boundaries because of the importance of that for the drought monitor in particular. Yeah.
Yeah, I'm not good at so much sensors for ground observations. I found the sensor brand is from another factory. Actually, we visited Campbell Science yesterday, right? So that being said, probably there are many factories to produce or generate the sensors. I just, as a user, just very curious if the sensors from a different factory or with a different band vary significantly each other, and eventually have a big impacts downward applications? Thank you.
Differences between sensors and yes. Yeah. So yeah, if I've got it right, you're asking about the implications of different models of sensors, like say, so what we did is at the beginning of the project, we had a test bed station where we ran all of the sensors together. And that, I mean, that could probably be done more broadly, say in different types of soils and that kind of thing. But we found close enough agreement to be able to work with that. And then it was thought that actually a lot of the Mesonets that are involved in this have some of the oldest soil moisture records. Like we've got some that go back into I want to say like late 80s or early 90s, and so we don't have a lot of them, but we did decide to make the switch on our probes from what we had been using previously for other reasons. But like North Dakota had been using a different type of probe, and they felt that keeping period of record with the same sensor was important, which I mean, there's certainly, I mean, it's certainly not a bulletproof system for sure, but we're not seeing, we didn't see it in the test bed, and we haven't been seeing issues with that. I assume you were talking specifically about soil moisture, right? Yeah. For what it's worth, that's documented in the in the metadata too.
And it's making me walk all the way back there. You see my belly, don't you?
So the build out of this network is quite a bit of work, but I'm curious what the strategy is for like 10 years from now, the maintenance. Is that has a strategy been assembled and agreed to and committed to, I guess. It's a lot of sites.
So the question's on maintenance and what's going to happen in 7 years.
So the timeline on this, the first, there were some pilot stations before that, but the first operational station started going in 2001 or in 21, and the last ones are scheduled to go in 27. They're the O&M, roughly, this is oversimplifying things, but basically the Corps of Engineers was funded to put them in, and NOAA is being funded to operate them. And so that's like, there is, let's see, I'm trying to figure out where it's, the budget that's in gets reauthorized every 5 years. So it is, I mean, it is something that we have to be aware of. I'm not particularly worried about it, for a couple of reasons. It has broad bipartisan support. It's, I mean, we had some pretty significant flooding recently in South Dakota, and lost. I mean, there was somebody who lost their life. There was the interstate closed down. A railroad bridge collapsed, and this was of big use to the River Forecast Center in preparing people for that kind of thing. I would say the other thing too is the drought monitor makes a lot of very big decisions, money wise, for these states, and the ability for that to be as well informed as possible is something everybody wants. So, and there's so much money tied to that, and to have that, I mean, really, this is this is expensive. This is an expensive project as far as what we're used to. But in terms of the kind of money that goes out based on the drought monitor and other types of weather related projects, it's a drop in the bucket. And the return on investment is so high. And they see that. I mean, and with 10 senators behind it, of different parties too, and the White House as well. So I think I'm not worried about it, I guess is. Yeah. So NOAA contracts with the states to buy the data. So it's not actually an O&M thing. If you're familiar with the National Mesonet program, it's basically an extension of that.
Thank you, Nathan. That was a wonderful presentation.